We're going to look at the two types of memories, short-term and long-term, and kind of understand how those are created and how those are stored and the process that we go through to retrieve those memories. So we'll start by looking at the short-term memory. And short-term memory generally holds information for anywhere from a few seconds to up to a minute in length of just the initial memory. And what's interesting about these memories is they're primarily acoustically coded. That is, we remember them through sounds, regardless of the original source. So we may read something, or we may see something, or we may smell something, but that information is coded and actually stored through our acoustics, through sound. So it's really kind of an interesting way that our body works on remembering things. And the general rule of thumb for memory is in short term is that your body can remember 7 things plus or minus 2. There's a lot of kind of thought that maybe that number is actually down to 4 now, and it's no longer at 7. But what is interesting is that that number can be adjusted through what we call chunking. And so you take a longer number or longer item of things and you break it into its parts. And that's how we're able to remember 10-digit phone numbers. That's more than the 7 plus or minus 2. But we're able to do it by chunking. So that's helpful for us. And items in your short-term memory are maintained by what we call rehearsal. And there are two types of rehearsal in your short-term memory. And so the first is what we call maintenance rehearsal. And maintenance rehearsal is essentially repetition. Keep repeating something so it stays in short-term memory until it can be used. And that is, think of when you try to remember a phone number and you say it time and time again. Okay, I got to remember these digits, got to remember this, got to remember this. That is maintenance rehearsal. It's repetition in order to remember it until you use it. The other is what's called elaborative rehearsal, which is organizing and understanding that information in order to process it and send it to long-term memory to be used at a later time. So you take the information in the immediate, you elaborate upon it and tuck it back into your long-term memory. So those are the two types of rehearsals. And what we find interesting about short-term memory is that information that we think about at a deeper level is better remembered. That's why you're better able to remember plots instead of individual words when you read a story. So the way in which you access information affects how you remember it and what you remember. We understand more, we remember more when we dig into deeper levels instead of trying to take surface level things. Surface level things leave us oftentimes with gaps in our memory. Other things that are useful for memory is rhyme. Rhyme oftentimes helps us to remember. There are various mnemonic devices, which are things you use to remember things. Acronyms are others. Rhyme's helpful. Then there's something that's called the dual coding hypothesis, and the dual coding hypothesis suggests that we remember things better when we associate words with images, and we remember that better than words alone or images alone. And that is the idea that because we are encoding two different things, there has to be some deeper level of thinking going on. There have to be more connections being made in your brain. And we're going to look a little more at that when we get to long-term memory. But that idea is that as we are making these connections, the more of them we can make, the stronger those connections are. So when we're connecting both a word and an image, we're doubling up on the strength of that connection. And then the other thing that's worth noting is that we tend to remember things that are personally relevant, and that is what we call the self-reference effect, and that is things that matter to us. Obviously, we tend to remember more than things that don't matter to us. It just kind of seems to be logical. Other things, items that are in short-term in memory can either be forgotten or encoded. And when we say encoded, that means it's stored for recall later. That is, it goes to long-term memory and we dig it back up later. So those are the two options. If they are forgotten, they're removed by either decay, which is just time, right? It can only stay in there for, as we said, a few seconds to a minute or so, or interference, and that is new information coming in, displacing the old information. So those are the two ways that items are forgotten and removed. Other things that are worth noting is something called the serial position effect, and that is when we're given items, we remember them sequentially. So we remember things from a list in the sequence that we see it. That is, we tend to remember, because of that, I should say, we tend to remember the first few items and the last few items. And those are called primacy, which is remembering the first few items, and then recency, which is remembering the last few items. We tend to not really remember the ones in the middle, just because it's not primacy or recency. They just kind of disappear for our memories. And recency lasts about a day. So things that we recall from recency stick around in that short-term memory for about a day or whatever. But primacy effect lasts longer. So the things at the beginning of the list we recall longer than the things at the end of the list because we encounter them first and kind of those sorts of things. So now we get to long-term memory. And what's interesting about long-term memory is it's really just this, it's easy to think of it as this giant web of information, and it's all interrelated. These things don't stand alone because there is so much information stored in our long-term memory that there's simply just like not enough room for these things to all stand alone. It's this network that works together. And the information that we store in our long-term memory is primarily semantically encoded. That is, it's based off of words and word imageries, and so word meanings. And so that's how we remember things, is through words. And some information is stored visually or acoustically, but for the most part, it's encoded semantically. That is through words and word meanings. And so we kind of have these interesting things happening. Memories in our long-term memory can be stored in a number of different ways. Some of them are listed here. So episodic memories are specific things that we have experienced ourselves. And those are things that we have kind of experienced and stored in that long-term memory. Semantic memory is also known as declarative memory, and that is facts, figures, general world knowledge, things around us, information you learn in school is all in this semantic memory. And then there's procedural memory, which are the skills and habits that we have. And this procedural memory, interestingly enough, tends to be relatively safe from damage. It tends not to be damaged very often, which is nice. That's one way of dividing up memories, is how we store it and how we experience it. Another way is whether it can be accessed consciously or not. And so if we divide memory in that way, there's two types. There's either declarative or explicit memory. That is memory a person can consciously consider and retrieve, episodic and semantic memory. If you're asked to remember, 5 times 5, or if you're asked to remember where you went to elementary school, those are episodic and semantic memories, and you can think about them and access them. But others would be non-declarative or implicit memory, is generally beyond conscious consideration. So that some of that is procedural memory, habits that you have. You can't really access those. You just kind of do them in general. And then priming and classical conditioning. So in classical conditioning, you are making memories, but you're not necessarily conscious of it. And so therefore, you can't really access those memories, or at least you can't access them well. Another interesting thing about long-term memory is that when we recall information, we are subject to what's known as state-dependent memory. And that is this, that we are more likely to recall information if we are attempting to retrieve it in a situation similar to where we learned it. So if you learn about psychology in your psychology class, then you are more likely to remember that information when you are inside that same classroom, versus if you try to recall it at home. That just points to our surroundings having an effect on how we remember things and how we encode our memories. This also applies to states of consciousness. So if you memorize things when you're in an altered state of consciousness, like on drugs or hypnotized, then it's easier to access that information back when you are in that same altered state of consciousness rather than when you are not. So that also affects kind of the way we interact with the world around us, and that is state-dependent memory. Our memory is stored in kind of a number of interesting and meaningful ways. First, let's take this apart. So accessing memory is thought to, no one's quite sure how this works. There's a few hypotheses floating around out there, but basically it involves the activation of semantic networks. So information is stored as an organized network. If you think of it like a computer or like the internet or any other network like that, it's stored in kind of a logical way, in a hierarchical way in many ways. And individual ideas do exist, and these are called nodes. And those nodes are connected through what we call association. So another way to think of this is if you look at a map, and the nodes are different cities, different points on the map, and the associations are different roads that lead to those cities. And so all of these memories are interrelated and interconnected in some way. And the strength of our association is related to how frequently we make a connection and how deeply that connection is made. So again, using the analogy of the cities and the maps, you have some of those roads may be highways, some may be dirt roads. They're not all necessarily the same. But based off how often we make associations and how deeply we make connections, that's how strong those associations are. Other things that's interesting is if we process information in different ways, we establish multiple connections, and that means we're better able to get to that information. So if you want to remember something, if you hear about it, if you read about it, if you write about it, and then if you watch a video about it, all of that different processing helps us to establish multiple connections, and it makes it easier for us to recall and retrieve that information. And so we can retrieve information, we can make that easier by building stronger connections to an idea. So if we have an idea, say memory, the more connections we make to that, whether that's through personal experience, whether that's through an article we read somewhere else, whether that's through a video we read somewhere else, but the more connections we start making to this idea, the easier it is to retrieve information about that idea. So that's why it's helpful when we're learning about something to present it in many different ways, in many different formats, for people to learn about. And then the other thing, the last thing is long-term memory. Again, just looking at it, there's something called what we call flashbulb memories, and flashbulb memories are deep, vivid memories, often in the form of a visual image associated with a particular event that has strong ties to us. So people will remember where they were on September 11th. Older generations remember where they were when they heard that JFK was assassinated, or where they were when they heard about Pearl Harbor. These are events that we really recall strongly, and so we have what are called flashbulb memories. Despite that, some psychologists don't think that these are any more accurate than other memories. They're unsure. They think there may be some psychological effect going on there to convince us that they are more accurate when perhaps they are not. And human memory is notably fallible. It's not very good. And so sometimes we remember what happened in parts. Sometimes we don't remember at all. But when we remember what happens in parts, we often try to fit pieces together of that event, and we sometimes just make it up because it seems like it's a likely scenario, and that's called memory reconstruction. One of these possible causes is what's called source amnesia, and that is attributing an event to a different source than where it actually came from. So if, for example, a child may read a book so many times that they begin to believe that those events actually happened to them rather than just happening in the story. And so they have what's called source amnesia. Other thing is that childhood, and not just childhood memories, but all memories can be reconstructed falsely by repeating suggestions and by misleading questions. Through this, we can create false memories, which we call framing. We can force people to remember things incorrectly by just suggesting things to them and repeating it to them time and time again. And eventually they internalize it and say, oh, that is what happened, when it really is not what happened at all. And because of this, we find that the memory is really bad. Human memory is notoriously bad. And that eyewitness accounts, which we use often in our criminal justice system, are only accurate about half the time. And so many of the memories that we have from our past, we've kind of created both a story around the parts of the memory that we do recall. So that's what we have going on in terms of short-term and long-term memory, where it's stored and how we access it.